Welcome to qnawire.
Here we have a situation where there is a girl standing on a plank. She's going to be moving or walking to the right, and we're going to find the velocity of the plank relative to the surface of the ice. To start off with that, we need to see what momentum is going to be. So, we know in an isolated system, momentum is always conserved. We start off with a momentum of 0, and we end up with a momentum of m1 v1 plus m2 v2. Now this is going to equal to 0 because, like I said, momentum is conserved and we had an initial momentum of 0. So now let's plug in what we know based on our situation. We know the mass of the girl plank system is going to be mg plus mp, mass of the girl and the mass of the plank, multiplied by the velocity of the plank initially. And that's going to be added to the mass of the girl multiplied by the velocity of the girl on the plank. And that's going to be equal to 0. Now we can subtract mg vgp from both sides, and that will yield the following. Now we have a negative on the right hand side because we subtracted from both sides. The negative is there for direction. I'm just going to finish off the problem for you first. We have to divide both sides by mg plus mp. And then we see our velocity of the plank relative to the ice is equal to negative mg over mg plus mp multiplied by vgp in the I hat plane, the x direction. Okay. So we know that the velocity of the girl on the ice is equal to the sum of all of the velocities that's present. The velocity of the girl on the plank and the velocity of the plank on the ice. So let's look at the momenta in this situation. We have the mass of the girl multiplied by the velocity of the girl from the perspective of the ice, plus momentum of the mass of the plank multiplied by the velocity of the plank from the perspective of the ice. And this is equal to 0, just like in part A, when we had initial momentum being 0 and our final momentum being this situation right here. And again, just like earlier, we can rearrange this equation. We want to find VPI to plug into the above equation, so MP VPI is going to be equal to negative mg VGI. So VPI, if you divide both sides by the mass of the plank, you will see you have negative mg VGI over MP. And now we can substitute that into the above equation right here. So VGI is equal to VGP plus negative mg VGI over MP. What you should notice now is that you have two VGI terms, so now we can combine like terms to find out what the velocity of the girl on the plank is going to be. which is what we were asked to find. We were asked to find VGI. So we can put those together and find VGI in terms of VGP. So let's add mg VGI over mp on both sides, plus, because it's negative, so now we can combine these two VGIs right here, and what we will end up with is VGP is equal to 1 plus mg over mp VGI. Now, of course, we want to find VGI itself, so we need to rearrange this again to get VGI equals. So that's easily done by just removing everything in the parentheses. I'll make the parentheses look a little bit more simple though, because this looks a little confusing. We can have mp plus mg over mp right here, multiplied by VGI. So now removing everything from the parentheses over, we end up with VGI equal to mp over mp plus mg multiplied by VGP. So in terms of vectors, this would come out to be, let's separate this out, VGI equal to mp over mp plus mg VGP I hat, because we are moving in the x direction.